it's Mr. Zimmerman, and welcome back. We're continuing our exploration of polynomials, and at this point, we can add and subtract polynomials. So the front of the side should be rather easy to complete. Let's go ahead and take a look at multiplying some polynomials together. So I'm going to show you how to use the distributive property, and then I'm going to give you an alternative in order to empower you in order to be precise. Let's go ahead and dive on in. So looking at this first problem, I have to multiply the polynomials together. And in the traditional sense, I would have to multiply this 5r to the fourth. I would have to multiply it to each term. Hence why it's called distributing, evenly distributing to every single term. Now, I have to multiply 5r to the fourth times 3r squared. Well, traditionally, I know 5 times 3 is 15. But it's been a while. Is it going to be r to the 6? Is it going to be r to the 8? I'm not too sure. So I'm going to go ahead and look at it in expanded form. R to the fourth times r squared is going to be equal to r to the 4 means I have 4 r's, okay. R to the second mean I have 2 r's. Well, how many do I have total? Oh, it's going to be 6. I just want to show you how a little bit of logic can go a long way in remembering some of the laws in mathematics. Remember, write things out as an expanded form. So that was just a quick review. Essentially, what we do when we multiply exponents is that we are going to be adding them. It's going to be r to the 4 plus 2. This only works when they're the same variable. Okay, so let's go ahead and multiply this out. I know that this first term is 15r to the 6. I'm going to now do 5 times 1. There's always an invisible coefficient, so it's going to be positive 5. Notice how I wrote the 5 down right away. Now, there is, just like there's an invisible 1, when there's no exponent, it's just 1. R is the same as r to the first power. So, how many r's are there total? 4 and 1 make 5. Let me be consistent and keep this red. And then finally, I have to distribute 5 times 2 is 10. How many r's do I have? 4. Voila. Now, an alternative is using an area model to represent this. I'm going to go ahead and draw a rectangle. I'm going to write my terms, 5r to the fourth. On the top, I'm going to write 3r squared plus 1r. I like to write my coefficients, and positive 2. And since there's 3 terms I'm multiplying in the grouping symbol, I'm going to have 3 boxes. And here, I'm going to do the same thing. 5 times 3r squared is 15r to the 6th. Likewise, this is going to be 5r to the 5th and 10r to the 4th. Use whichever method you like. This is for the people who are traditionally stronger in their number sense. I recommend this if you've never quite conquered the skill. So let's go ahead and do a next one. Let's go ahead and do negative b to the 5th. I'm going to go ahead and write out my rectangle. Negative b to the 5th times ab squared plus a minus b. There are how many words in the grouping symbol? 3. 1, 2, 3. Notice how the sign is in the front of the variable. That's important to keep it organized. And now I'm going to multiply this quantity times this. Well, let me just kind of count my variables. I have a. But first, actually, I have to keep track. What is a negative times a positive? A negative. How many a's do I have? 1. How many b's do I have? 7. Likewise, I'm going to repeat this again. A negative times a positive is a negative. How many A's do I have? How many B's do I have? Again, what is a negative times a negative? A positive. How many B's do I have? And voila, I get negative AB to the 7th minus AB to the 5th plus B to the 6th. And notice how I'm writing it in descending order. This is considered standard procedure. Okay, now for this last example in this video, I want to go ahead and show you how to handle when there is a binomial being multiplied. In each of these examples, there was a monomial, one term. I'm going to go ahead and show using the area model. Now, just as previous, I'm going to go ahead and write the second term on the top, 3x and positive 5, making sure I have plenty of room. Now, I'm going to add a second rectangle because there is a second term. Now, I got to make sure I have the boxes. So multiplying a binomial by a binomial will result in 4 products. This is from a result of this 2x being multiplied to the 3x, which is going to be the 6x squared, the 2x being multiplied to be the 5, which is a positive 10, 3 multiplied to be 3x is a positive 9x, and likewise a 3 multiplied is a 15. I like to represent it this way, where I can easily combine like terms to give my final answer. For standard form, I want to go in descending order, so I'm going to write 6x squared. Next is the positive 9x. And now I see the positive 10 and the positive 15, and I'm just going to go ahead and combine it. Voila! The binomials resulted in a product, which is a trinomial. That's it for now. Go ahead, play with this on your own, and I'll see you next time.